Hello everyone, welcome to MEP Booster. So in this lecture we'll discuss single phase versus three phase system. After the end of this lecture, you would be able to understand what is the difference between single phase and three phase system. So let's start. So remember, single phase and three phase systems are two types of electrical power supply configuration used to deliver electricity. Okay, each has distinct properties, applications and efficiency level based on the requirement of the system it powers. Okay, so we'll discuss one by one. First we'll see the basic concept of single phase and three phase system. Okay, so in that, if you see, first of all we'll talk about the single phase system. What is it? See, a single phase system uses one alternative current. Means in short you can say AC waveform to supply power. Okay, and it typically has two wire. One live, or it is also called as a hot wire, which carries the current, and second neutral wire, which provide the return part for the current. Okay, sometime an additional ground wire is included for safety purpose. Okay, so in some cases it may have a ground for safety. Is it clear? So the characteristics of single phase system is what? First thing, see, it is simple in design, means it is easier to design and maintain. Even here in single phase system, fewer components are used and it is cheaper wiring, make it more economical. So it is cost effective also, and this type of system, single phase system, is suitable for most residential houses and light commercial uses like fan, lights, TVs, etc. But one limitation is there. This system, single phase system, is not ideal for running heavy equipment or machine, okay, that required high power. For that we have to go for this three phase system. Okay, so it is written it requires simpler and less expensive equipment as only two wire are needed to complete the circuit. Now we'll see about the three phase system. So what is it? A three phase system uses three alternating current of the same frequency, each 120 degree apart in phase. Okay, so it has three live wire for phases and may have a neutral wire optional based on the system configuration. May also include a ground wire for safety purpose. Okay, so the characteristics of three phase system is what? As you know that here the power delivering is very smooth. Due to the 120 degree phase differences, power deliver is more continuously and stable, and it can carry more power using less conductor material compared to a single phase system. So you can use this three phase system in industrial environment, large building, factory and heavy machinery. Okay, because it can handle more power without using overly thick wire, so making it more efficient for high load application. Okay, so it is more complex but can handle more power without needing as thick wire as single phase for the same power output. Okay, so these are the basic concept of single and three phase system. Hope all of you understood about this. Now we'll move to the second point here, voltage and power delivery. We'll see the difference between single phase and, so see, in single phase system normally what happens, the voltage between the live means hot and neutral wire is usually 120 or 240 volt depending on the region. Okay, is it clear? For example, in North America it is typically 120 volt, while in many other country single phase voltage is around 230 to 240 volt. Correct? Next is power delivery is not constant in single phase system due to waveform oscillation. Is it clear? The power is delivered in wave, one sine wave that rises and falls, meaning the voltage fluctuate. So because of this oscillation, the power supply is not continuous, which can lead to voltage dip or less efficient performance under heavy load. Okay, Now when you talk about the three-phase system, so here the three-phase system voltage commonly operates at 208 volt, 40 volt or higher depending on the electrical system and application. So this is common in commercial and industrial setup, okay? And here it provides constant power due to the phase shift between the three waveform. Okay, three-phase system uses three separate AC waveform, each 120 degree apart. Okay, and these phase differences ensure that power delivery is constant, minimizing dips and interruption. Okay, so this is especially beneficial for equipment that required a stable power source like motors and HVAC system. Clear? Now we'll see as per efficiency and power capacity what is the major difference. So when you talk about the single phase system, so remember single phase system are less efficient for high power load. Why? As it has more significant voltage dips, so it is not suitable for high power devices and typically deliver power in lower capacity, making it ideal for household appliances and small electronics. Next is three-phase system, which is three-phase system are much more efficient, especially for long distance power transmission. Okay, so due to constant power flow, energy loss in this system is lower and equipment runs more smoothly. And it can carry more power without needing to increase wire size. So make it perfect for industrial setting, commercial building and heavy machinery like compressor, large HVAC system, pumps, etc. Okay. Next, let's see the application where we have to use the single phase and three phase system. So in that, single phase system is best suited for residential use, small offices or light commercial setting. Why? The reason is why? Because see, these environments typically require less power and do not have heavy duty electrical loads. For example, lighting, heating appliances. In lighting normally we have LED bulbs, tube light, okay. And in heating, which type of equipment? Geyser, electrical heaters and appliances like TVs, refrigerator, fan, washing machine, computers, etc. Okay. Is it clear? So it is best suited for residential use, small offices or light commercial setting. Yes, some example is given. The next one is the three-phase system. So three-phase system common in industrial and large commercial area. Why? Because see, these environments require continuous, stable and higher power for operating heavy equipment. See now, example includes operating heavy machinery, large motors, HVAC systems and high power equipment. Okay. See the example calculation. Let us calculate the power consumption of a device with each system. So first we'll see the single phase system. Suppose let's say you want to calculate the power consumption of single phase system. So formula is written here, VI power factor, voltage into current into power factor. So assume a 120 volt single phase motor with a current draw of 10 ampere and a power factor of 0.9. So by using this formula you will get 1080 watt. And same way, if you are calculating the power consumption of a device for three phase system, so the formula will be little bit different. Here see √3 is added. So when you calculate, suppose assume here 400 volt three phase motor with a current draw of 10 amperes and a power factor 0.9. When you substitute the value, you will get the power consumption of a device 6235 watt. Okay. So in this way, normally we need to calculate. So now here you can see the summary example. Suppose if you were setting up a small workshop. So for simple tools like a drill press, lights and a few computers, single phase power would be sufficient. But if you are running industrial grade machine, for example CNC machine, compressor, so three phase power is preferable because it provides a sturdier, higher capacity power supply, which would keep the machine running smoothly and efficiently. Okay. Now we'll see the single phase system standard rating. First, voltage level. See, common voltage is given like 120 volt North America, 230 volt Europe, Asia, Australia and most part of the world. So 120 volt is common in North America, means USA, Canada, etc. Okay, and 230 volt common in Europe, Asia, Australia and most other part of the world. So these voltages are what you typically get at the wall socket in homes and powering appliances. Okay. See, the power rating is also given. Power usage range from 500 watt to 3 kilowatt for residential appliances. For small commercial and industrial application, typically up to 10 kilowatt for low demand equipment. Okay, I am talking about the single phase system standard rating. Okay, voltage level and power rating. Same way, lighting circuit and small motor generally below 5 kilowatt. See the example appliances: lighting circuit, refrigerator, washing machine, air conditioner and other household appliances. Okay, so these are the single phase system standard rating. Same way, now you can see the three phase system standard rating. Voltage level, common voltage in North America normally 208. North America, now I think all of you know that, in USA, Canada, etc. Voltage, standard voltage rating should be 200 for three phase system, and 400 volt is in Europe or Asia, 480 volt in industrial North America, 600 volt for heavy industrial application. Power rating is given for commercial and light industrial application, commonly between 5 kilowatt and 50 kilowatt. And if it is a medium industrial, for medium industrial application, ranges from 50 kilowatt to 250 kilowatt. For heavy industrial and utility application, typically above 250 kilowatt, and can extend into the megawatt range for large facility or plants. Okay. Example equipment is given here: large HVAC equipment, industrial motor, manufacturing machinery and equipment used in power generation or heavy industry. Okay. So these are the three phase system standard rating. So now the topics which we have covered in this section, we have discussed single phase versus three phase system in detail. So hope all of you enjoy the session. See you in next one.